Hello, this is Mrs. Bellotti again. We're going to go ahead and take what we know a step further in our 9.2 pre-assessment number 1. We're going to take a look at percent yield. So I'm going to move forward to question number 5. Question number 5 asks, what is the measured amount of product obtained from a chemical reaction? These words, measured amount, means that that's the macroscopic scale. That's something that I can actually measure. So we call that our actual yield. Question number 6 asks something a little bit different. What is the maximum possible? Now that word possible means that it's questionable, right? We're not completely sure, but it is possible. Well, our maximum possible product is called our theoretical yield. Now, to calculate our percent yield, we need our actual divided by our theoretical yield. And we multiply this by 100 so that we have a percentage. Let's take a look at question number 7. Now this is going to take everything we know about stoichiometry, our molar relationships, our proportions with molar mass, all of it is going to come all together. I know there's multiple steps to this. Just think about every step logically. What do we know? Well, we need to calculate the percent yield, all right? So this is our question. Our final answer is, what is the percent yield? We are given 6.24 moles of sulfur trioxide. Let's identify where sulfur trioxide is in our equation. It reacts with an excessive amount of water. We have that right there. And then finally, we're producing 5.75 grams of sulfuric acid. Here is our product. Okay. If we are actually producing this amount, this is our actual yield. You have to use stoichiometry to calculate the percent or the theoretical yield, okay? So we don't know if this is possible yet, okay? I mean, it's what we actually produce. Let's go ahead and calculate what is possible. You have to start off with your BCA tables. So I'll go ahead and put this down. We've got SO3 plus H2O yielding H2SO4. So sulfur trioxide plus water yields sulfuric acid. First things first, check to see if we have a balanced chemical equation. That should be the number 1 step in any stoichiometric calculation. Well, I've just double checked it. It's balanced. That's good. One less step we have to do. Okay, what do we know? Well, we start off with 6.24 moles of sulfur trioxide. We're going to use it all, okay? We're going to use it all and see what we can produce. Well, let's look at the coefficients. If nothing is written, we assume that it is a 1. So we have here a 1-to-1-to-1 ratio, which is going to make things pretty easy for us. Before the reaction occurs, if it's a 1-to-1-to-1 ratio, I've been told I've got an excessive amount of water, and obviously I have no product at the beginning. At the beginning of a reaction, nothing's happened yet, so no product exists. Now the change occurs. I'm going to use up all of my sulfur trioxide. I am going to also use up 6.24 moles of my water. Why do I know that? Because remember, it's a 1-to-1 ratio, okay? So the same number of moles will be used. Will I be left with 0? No, because it was in excess to begin with. Yeah, I'm going to use up 6.24 moles, but I'll still have some left over. All right, this 1-to-1-to-1 ratio tells me that I will be able to produce 6.24 moles of my sulfuric acid. So my end product is 6.24 moles of sulfuric acid. So let's go ahead and figure out what this is. This is what? My theoretical yield. So let's just plug this in. Let's see what happens with our percent yield calculation. I've got percent yield. It equals my actual yield, which was 575 grams of sulfuric acid. And I've got my theoretical yield, 6.24 moles. Uh-oh. Why does this not work? It doesn't work. I cannot do a percent calculation unless the units agree. They have to be the same units. So I know my actual. I do not know my theoretical yet. Let's go ahead and calculate it. Okay, here's my theoretical yield, but we need to convert our moles into grams. And this is where we need our periodic table to do that. Okay, with our periodic table, let's take a look at sulfuric acid. Let me go ahead and give us a little bit of space here. All right, we have H2SO4, hydrogen, sulfur, and oxygen. Looking at my periodic table, hydrogen is 1.01. I have 2 atoms of it. Sulfur is 32.07 grams for every mole. In this situation, I only have 1. And then oxygen is 16 grams for every 1 mole. And I happen to have 4. So adding all of these together, okay, what did you guys calculate? Did you do it with me? I hope. 98.09 grams for every 1 mole of sulfuric acid. That is called our molar mass. Now we're going to take this information. I'm going to go ahead and transfer it over here. We're going to use that relationship so that we can calculate how much our theoretical yield is in the units of grams. So we've got 98.09 grams in every 1 mole. I know that theoretically I can produce 6.24 moles. So let's go ahead and solve for x. Theoretically, I should be able to produce 612.0816 grams. All right, let's make our lives a little bit simpler and look at significant figures. I've got 3 sig figs in my given. I've got 3 sig figs in my second given. So we'll go ahead and round this to 3 significant figures. So it'd be 612 grams that can be theoretically produced. Now I can go ahead and do my percent yield calculation. We'll go ahead and give ourselves a little bit more space. Percent yield is actual. Our actual is 575 grams. Our theoretical is 612 grams. And we multiply this by 100%. Ultimately, my percent yield was very good. It was 93.954. It keeps going. This is why we use significant figures. It's always best to be able to round to the appropriate significant figures. In this case, we're going to go ahead and round to 93.9%. which is right here. I know there are many steps to these calculations. Do your best. Go through this pre-assessment a couple of times and make sure you get as many points as you can, and reach out to any of your chemistry teachers for help.